Hi, you guys. Welcome to the gas units. So fun. We're going to be talking about gases today and what makes them unique and learn a little bit about pressure and how to convert between units of pressure. Let's get into it. So, gases are special for reasons that you already know, we already studied, so I don't know how much of this slide you need to write down, but the reason that they're unique is because they have a lot of space between their molecules, which is much greater than a liquid or a solid. Not that they're super far apart, like they're not like inches apart or anything, but they're still very, very close, but a lot further apart than a liquid or a solid. For that reason, they're considered fluids because they can flow. There's a lot of space between their molecules. So like those commercials maybe you see on TV, I don't know if anyone actually watches TV anymore or if they even have commercials anymore, but like where they like blow like a smoke over the car and you can like watch the smoke flow over the car or something like that. That's an example of how gases are fluids and they flow. And like they're all around us. So when you are walking through the classroom or you're walking in your house or whatever, like you are in a sea of gas, like you're walking through it and it's flowing all around you, no matter where you go. And because they have so much space between the molecules, they have a lower density than liquids or solids. Gases, we've talked about this a little bit. Also, they're really compressible. There's like mostly empty space. Again, even though the space between them is not that great, it's still enough that most of the gas is actually empty space. And if we had a syringe, I would show you, but we don't. So we're moving on. We know from last unit that solids have a certain shape and volume, and that liquids have a certain volume, but their shape can change. But gases, again, as a review from last unit, gases completely fill their container, so you can be any shape and volume, and you can expand them or contract them depending on how much pressure you put on them. So like all the gas in the room, wherever you are, you could take and start to smush it together and you could put it into your hydro flask, and vice versa as well. Like all the gas in a hydro flask, you could open up and the gas molecules would spill out to fill the room. Okay, so gas molecules do like interact with us and things around them and themselves, and those collisions of gas molecules are what we call air pressure. And we're experiencing, you maybe don't know it, air pressure, but you are like experiencing it at all times right now. There are trillions and trillions and trillions of little gas molecules bumping into you every square inch of your body. And that net effect of that, the fact that they have so many of them, even though they don't have a lot of mass, and they're not traveling super fast, but they do have enough mass, and they are traveling fast enough that you can feel that. And maybe you don't recognize it because you've been around for, kind of born into gas pressure. But maybe if you have like older people in your lives who are like, like my knee hurts when it's going to rain, like that is an example of like, your body changing with pressure. Or maybe if you've driven to Minneapolis and you go down into the river valley by the Minnesota River and the bridge, like you'll notice that your ears will pop. That's how your body regulates different gas pressures. But the idea is basically that these gases are small, but they have some mass. They are always in motion. They're always bumping into things. And when they do, they transfer that kinetic energy to stuff. We just call this pressure. It's like a little mini collision with tiny, tiny little gas molecules. Again, if you have enough of them, then it actually causes an effect that you can feel. And if you look on they measured that with a barometer. And if you look on like the news or something like that, again, obviously you don't watch the news, but like if you're old, maybe you watch the news. So for all the old students in my class who are like in their 80s, if you watch the news, they'll like put the pressure on the news and they measure the barometer. In this part of the world, the barometer usually measures about 30 inches. And so maybe they'll say 30 inches of mercury. Maybe you recognize that. That's just a measure of pressure. And every part of the world's a little bit differently, but that's just how you measure it. Which is pretty common to report on the news. So anyway, we call all those collisions pressure. You can measure pressure all sorts of different ways. And just like probably in the United States, the one that most commonly is like pounds per square inch, PSI. But in other places of the world, obviously, you're going to use other things like pascals or kilopascals. Pascals is a pretty small measurement of pressure. Kilopascal is more commonly used, so that's one way you can do it. Atmospheres. The atmospheres was basically like invented. Some genius came along and said, instead of having a bunch of different pressure measurements, why don't we just let the pressure at sea level equal 1? And so that's what they did. So that's how atmospheres was invented. And then millimeters of mercury, I already mentioned that. Of course, in the United States, we measured as inches of mercury, but a barometer is how you measure pressure. It pushes mercury up a tube, and they actually just measure the length of that, how far the mercury has gone. And that instrument, barometer, we can report as inches, but of course, most countries report it as millimeters of mercury. Also called a torr. They mean the exact same thing. They just have different labels. And again, pretty common to report any of them. Kind of like how you have like lots of different ways to measure length. You know, you have feet, you have inches, you have centimeters, you have meters, you have miles. There's a lot of different ways to measure pressure too. And so here are just 3 of them. And then of course, pounds per square inch. There's a 4th one. Of course, that's the one that we most common, like in America, if you're filling up a tire in your car or a soccer ball that you have to blow up to a certain pressure, those are the label that you'll see on it is PSI. Everywhere on Earth, the pressure is different. Imagine like it's a sea of gas sitting on top of you right now, and the gas column that you're like underneath goes all the way up to like the stratosphere. It goes all the way up to like the end of the Earth's atmosphere. So all of that gas is sitting on top of you, but every place is different. Like if you're at, if you're at the sea, there's more gas sitting on top of you. If you go up a mountain or a plane, there's less gas sitting on top of you. So it's useful to compare them. And so what scientists have done, is create a standard basically that says that standard temperature and pressure, STP, which is equal to 0 degrees Celsius and 1 atmosphere. So when they do experiments, they usually carry them out at those conditions, because the results of your experiment, whether you're here in Minneapolis or let's say in Denver, would be different if you were dealing with different gases, because the pressure is different in Denver than the pressure is here. So a lot of times for like bigger scientific experiments, they will sort of correct that pressure to STP, which is 0 degrees Celsius and 1 atmosphere. It's a number. It's just an expression that means 2 numbers. Standard temperature is 0 degrees Celsius or 273 Kelvin, and the pressure is 1 atmosphere. Then if you are able to take those, and you can actually use them as conversions. And so this is pretty commonly, you don't have to memorize any of these numbers, but these are the numbers you would get on a worksheet or quiz or whatever that you would use to convert different things. So at STP, 1 atmosphere is equal to 101.3 kilopascals, is equal to 760 millimeters of mercury, which is the same as a torr, and it's also equal to 14.7 pounds per square inch. That's the pressure at sea level, just expressed in different units. Much like you could express, how tall you are in meters or feet or inches, this is just how you express the pressure and sea level at just different measurements. So you can use them as conversion factors, of course. Anytime 2 things are equal, you can convert between them. Like if I told you that the pressure outside right now was 1.1 atmospheres, could you convert that to kPa? Of course you can, and it's actually pretty common. And I'm going to do that on the next slide, I think. Oh, hey, there it is right now. So let's switch. So if you wanted to convert between 2 things, you would just use those 4 numbers we have before, which I'm going to switch back to. So you'll see them right there. The 4 numbers right under where it says add STP. You only need to pick 2. Whichever 2 you're dealing with, you use those as equalities, and that's what goes in as your conversion factors. So if I was going to convert 2.18 atmospheres to millimeters of mercury, I would say 2.18 atmospheres. That's terrible. I'm going to do better for you guys. Atmospheres to millimeters of mercury. So you start with the 2 numbers from the 4. So if I was back on here, I would pick atmospheres, and I'm going to millimeters of mercury. So I'm going to use as my conversion factor that fact that 1 atmosphere equals 760 millimeters of mercury. So the 1 atmosphere goes down here to cancel out. Conversion should be pretty commonplace for you now. You got 760 millimeters of mercury on top. And then, of course, the atmospheres cancel out. And you just converted your atmospheres to millimeters of mercury, and the answer to this one is 1656.8 millimeters of mercury. By the way, millimeter of mercury is the same thing as a torr. They mean the same thing, and you can have that as your label as well. Just truly, there is no difference. Okay, for the other ones, if you'll try the other one, so 78.5 kPa to PSI, so you take your 78.5 kPa, and you want to convert that into PSI. So you're going to use those 2 numbers from the 4 on the other slide here. So we're saying that 101.3 kPa equals 14.7 PSI. And you just pick the one that you want to get rid of. It goes on the bottom. So I say 101.3 kPa equals 14.7 psi. They just cancel out. And then, of course, the math is 78.5 divided by 101.3, and you get 11.39 pounds per square inch. So you can convert all of these very readily using those four on the other slide here. These guys, those four, that is where the orange little square is. That's what you would use to convert. Again, you only need two of them. So if you're going to convert between atmospheres and kPa, you only use those two numbers. Hey, I made a slide for homework. Here it is. This is due tomorrow. Okay, this has been super fun. Everyone take care now. Bye.